Morning and good evening. Am I audible, my dear friends? We'll wait for 2 more minutes so that other also can join. From today onwards, the class is going to be more interesting. Okay. The rest of the classes, the rest of the other 9 to 10 classes, you will have very interesting sessions. Okay. So whatever so-called boring and whatever so-called some kind of a complexity involved in knowing the some of the fundamentals is over. Okay. Now you will listen, you will enjoy the sessions from now on, from today onwards. So today we will talk about very popular theorem. Okay, it's called Central Limit Theorem. Popularly known as CLT. Okay. So before we move on to this discussion, okay, let me summarize some of the notations that we are following so far, and I just wanted to bring it to your notice once again. So this is sample. Okay, let me write this as statistic sample. This is population. Size is the statistics. I'm looking at it. When we look into the sample size is denoted by small n. When it comes to the population, it is denoted by capital N. Mean. In case of sample, we always call that as average. In case of population, we always call it as a mean. In case of sample, it is always represented by X bar. In case of a population, it is always represented by what? Mu. Next, standard deviation. Okay, standard deviation. In case of a sample, or rather than standard deviation, let us change it to variance. That will be much better. Variance. S square. Capital S square is called as sample. For population, it is always referred as sigma square. So from here, if square root of my variance will give you your standard deviation. So this is the notation that we followed so far. Okay, I just wanted to bring it to your notice once again so that you will have the clarity. Today, let us please pay some attention. Please pay attention with me, okay? Because this concept is very important concept, and it is easy concept. It's not a rocket science kind of a thing. So we are still in the inferential statistics. So inferential statistics, what it does, based upon the sample data, it will help us to infer the population parameters. So far, you have not seen how we have actually calculated from sample to population statistics. Today, we will go through that part, how this activity is going to be done. Okay, very interesting concept. So generally, if you look into any sample, right, you pick up any sample and you look at the size of the sample. Suppose Lagadapati Rajagopal, he released who are going to win the elections. So for that, he collected some sample data, and on that sample data, he has done some analysis, and then finally he came out with some kind of a projection stating that, or some kind of a prediction stating that so and so party is going to win by so and so number of so and so number of seats. So that is how he actually arrived at. Okay. So now generally what happens is, sometimes people collect the data from the sample, they collect the data, they extrapolate on the data, and they do some repair job, either add or delete or divide or multiply with some kind of a numbers based upon their past history, and then they will say this is their prediction, and they propaganda, they actually do a lot of marketing around this. It's all about some kind of a gimmick many people do, but that is not going to help anybody, because what is the guarantee that the prediction is really accurate? So the question comes here, whether you use data science methodologies or statistics principles or whatever it is, how accurate is my prediction? How accurate my sample data is able to predict my population parameters? How accurate is always the question. This is always the question. Let us assume that, okay, there is some kind of an accuracy as actually brought into your process of predicting the population parameters. Next question comes from here, that how much is the error? How much is the error? Is the next second important question that you need to answer. As a data scientist, these three dimensions are very important to you. What are these three dimensions? One is collecting the sample. If at all you are collecting the sample, how much sample that you have to collect, and once you collect the sample, how accurate your sample data is able to give you the information so that you can predict your population parameters, the second dimension. And the third one is, how much is the error that your prediction is actually able to project. So these are the three dimensions which you need to really understand, and you need to plan properly around this. Okay. So before moving on to this one, before moving on to the further down, I wanted to just give you a variance of x, which we used to call it as this. You can write it as, for sample, we call it as s square. Okay. or for this one you are going to, for population you are going to call it a sigma square. So S square, from the definition we have seen this earlier, sigma of xi minus x bar whole square, where I is equal to 1 to n divided by n minus 1, because this is for sample. Guys, very fundamental. Probably the first 10 classes itself we talked about this definition. Don't forget this. This is important definition which you need to keep in your mind. That is why I said whatever the formulas that you are learning in this class, you have to remember everything. You may ask this question, how can I remember all these things so much? My question is, when your teacher is remembering, what is your problem? You have to remember. Of course, R and Python remove that kind of a problem for you, thanks to R and Python programming. But still, if you remember these formulas, it will really, you can get a tremendous command onto the subject, and then you can actually contribute a lot in solving the business problems. Okay, and the customer will gain a lot of what do you call confidence on you. Okay, now I am defining a random variable called x1. I'm defining a random variable x1, or sorry, rather I can say, let me change my statement. What I'm trying to do here is, I am trying to, now take the example of same Lagadapati Rajagopal. What he did, or what he does basically is, he will be sending up, he will be identifying few people, and he sent them to different parts of the state and asked them to collect the sample from all these places where they are going. What sample? They have to go into the people. They have to go, let's say they have gone into, let's say, Karimnagar. In Karimnagar area, they will be identifying few potential area, I mean few areas, and they will ensure that the mix of the people that they are selecting are from different regions where different religion people are living. So they go and talk to these different people, and they'll ask, which party did you vote for in these elections? Then based on their feedback, they collect the data, and that is how the sample data is going to be collected. Okay, so you have sample 1, you have sample 2, you have sample 3, sorry, you have sample 4. Like this, you may collect probably, let's say, sample k. I'm giving k word, okay? Not n, maybe 10 or 15 samples, or maybe 20 samples, maybe 30 samples, whatever it is. Okay. Now, when you are collecting the sample, you need to be intelligent enough. Why you need to be intelligent enough? In this sample, let's say this is my sample. Am I including various religion people? Is one dimension. One is religion. Second, am I including all kinds of people? That means, am I including only young blood who are just between 21 to 30 years old, or am I including the all age group people? All age group people. Did I include male, female, and transgender? Did I include politicians? Did I include employees? Like that, there is a criteria based on which you have to identify how I'm going, I mean, what kind of a people that I'm going to involve in my sampling. But the more width or the more variety that you cover will yield you to a better result. Okay. will lead you to a better result. What better result? Better result in terms of predicting who is going to win the election. Who is going to win the election? Okay. Suppose if I don't let's say there is somehow I missed this type of segment people. That means the data that you have collected, please be with me, I'm going to use the word, it is biased information. Why it is biased? Because of the nature of the group that you have included, the information is basically biased, or information is more favorable to certain segment or certain party or certain group. Guys, are you with me? Please respond. Are you with me? Yes. Okay. So the question is, when I'm trying to include different segment of the people into my sample data, okay, how many such segment people I have to include is one question that will come into your mind, because there are so many variety of people are possible in the democratic country, in any religion country where the country is ruled by the religion, then also you have to look at the various possibilities in grouping the people. Okay, so in such a situation, suppose I have collected, let us assume that S1 sample is ready. In this sample I have the data, something like this. I have the data, I collected the data. Okay, after collecting the data, now what I do, i I from this data I want to achieve this. This is my sample, this is my population, right? This population mean, this is mu, is unknown. We don't know what is the total population. I mean, what we don't know what is the mean of the total population. This mu is one of the statistic. Statistics can be mean, it can be standard deviation, it can be variance, it can be minimum value, it can be maximum value. There are so many. That is why it is called statistic. Okay, so this is we are trying to make an attempt to from here to here. That means from sample to population. Now, when I in this process, when I am not able to include right set of the segment people, you are saying that the information is going to be biased. When the information is going to be biased, now the problem is, okay, can I accurately identify my population mean? Can I tell you who is going to win the election? Not. You are not. So what you will do, from here to here, point estimate is not possible, but you can always give a range. That is why if you look at it, any elections for what you call projection, forecasting, it is always says that Congress party is going to win somewhere between 80 to 100, like this. This is the range that they define. Why that range? Because the information is going to be biased. Friends, are you with me? Now the question is, this is the situation with one sample. Now, what about S1, S2, S3? What about S2, S3, S4, S5? Right? So, if I plot the information, if I plot an histogram with various samples, which I'm calling it as X bar, because your S1 sample is having X1 bar. It has, this is X1, this is a mean of sample. S2 will have X2 bar. Like this, it will go. Right? So, All these x1 bar, x2 bar, x3 bar, if I look at this, x1 bar, x2 bar, x3 bar, it goes up to xk bar, let's say, let us assume. Because there are k samples which I have collected. Now, looking at this on my y-axis, I am going to plot my probability density function. When I make this probability density function, the graph is going to be like symmetric. It's going to be like bell curve. Okay, or it can be a bell curve, but something like this, or it can be something like this, or it can be something like this. Okay, so when you have collected the data like this, and when you plot this statistics of what is the statistic mean, if you plot this mean data like this, different shapes of the data are possible. When such data is possible, which distribution you need to apply, you need to be careful about it. That is the reason we studied about all those previous distributions. Okay, this is what happens. First, initially, you know what is the business problem here. Here, the business problem is to identify or to predict which party is going to elect the or which party is going to elect in the elections. That is your problem statement. Now, as a data scientist, you went ahead and collect the data. You met different people and you collected the data. Now you plot the information. Now, whether the data which I have collected, is it a normal data? Is it by Bernoulli? Is it binomial? We don't know right now. You simply collected the data. After collecting the data, now you plot this information using the histogram. Let us assume that these are all the various possible distributions which you can see. Now, end of the day, what I'm doing, I am trying to predict the value of my population. Predict in the sense, I am talking in terms of probability. And knowing the probability is extremely important because that will decide the rest of the whole story. My dear friends, are you with me? Okay. Okay. Now the question comes. I plot this information. Let us assume that I plot this information. This is my X bar. This is my probability density function. Let us assume that you got a curve something like this. Now the question is, what is this? The center of this one is, the center of this is another mean. What is this mean? This mean is actually mu, because from so many samples data, we are trying to find out the population mean, which is mu. So the center of data will be mu. But question is, are these number of samples, suppose I collected only k samples, is this k samples is good enough to achieve to get my mu? We don't know. Guys, are you with me? We don't know. Since we don't know, we always give you a range here. We always define this in the form of range. When I am defining the range, okay, now your mu, your sample mu, that is your X bar plus or minus, let's say, is it 1 or X plus or minus 5 or x plus or minus 10 or any number. That means what I'm trying to say is, how much will be this plus or minus? So this means, let us say something called 2.5. That means this my mu value of the population is 2.5, let us assume. Or rather, sorry, what, not 2.5. Rather, I say the elections mu, population election mu, let's say 180. If you collected S1 sample, probably S1 sample X1 bar, X1 sample mean, which is X1 bar, might be very closer to 180, possible, or might not even closer to 180, because of which we are defining the range. So the range which I am defining, question is, how close this range to the original population is the question. Are you with me, friends? Is it interesting? Okay, so I'm moving on. Before that, let us define the definition of what is this is called. This way of okay, probability density. This everywhere, this is the x1 bar, like this. Okay, collecting the sample and calculating the mean for each sample and taking those mean values of the samples, again construct another histogram with those samples, which will eventually give you some kind of a mean, which is nothing but your mu, that is your population mean. This way of representing the distribution, data distribution, is called as sampling distribution. Please remember, note down in your notebook. Is called sampling distribution of mean. Mean is a statistic. Guys, remember this. What is this? See the wording. Sampling distribution of mean. Whenever you hear this word sampling distribution, not sample distribution, there is a big difference here. That is what I'm trying to show it to you. Sample distribution of mean is different versus this. Here, this one I call it as mu of x bar. This is mu of x bar. Okay, this one is simply x bar. Guys, be with me. Okay, this is, many people don't understand this. Okay, sample distribution of a mean means basically it is an x bar. You collect such x bars from various samples and again you plot the histogram for those means, then excuse me, it is called as sampling distribution of mean. And the mean of this picture or this one is called as mu of x bar. Okay, now in this sample, the standard deviation is your square root of s square here. Sample distribution is square root of s square. But here, the sample mean, this sampling distribution mean, let me write this. The sampling distribution standard deviation is sigma by square root n. In other words, is sigma square by n. This sigma square is population data from is population variance, or this is sigma is standard deviation. Okay. Now the question, again, going back to the same discussion part, let me draw the picture here for your clarity. I'm drawing the picture here. Okay. This is your mu of x bar. This is all about x bars. Okay. Here, the standard deviation is sigma by square root of n. Okay. Sigma by square root of n. Okay. Now, there are two conditions. There are three conditions, or rather I can say properties. People call it as properties. What is this properties? Properties of sampling. Remember, properties of sampling distribution. What is this? This is first one. Very important. Mu of x bar is nothing but mu. Mu of x bar is something which you got it from this graph or this picture. Okay. Because there are few samples. How many samples you collected? You collected k samples. You have k samples. From the k samples, whatever that you are going to arrive at, that one you are calling it as sample. This is calling it as population mean. This is a population mean. Okay. Then second property or second condition. The standard deviation is nothing but sigma by square root of n. N is a size of the population, sorry, size of the sample. Whereas this sigma is standard deviation of the population. Where you got this number, how do you derive this one? You don't bother about it. That you don't need to really go through that depth. But remember this information. Third one, if my sample size is greater than 30, okay, the data distribution means the curve, this curve, the data distribution, it becomes normal distribution. Now the question, guys, is that clear to you right now? This one, these three conditions. Mu of x bar is equals to mu. Standard deviation of my standard deviation is equal to sigma by square root of n. Okay, and n is greater than 30. It is then the data distribution becomes normal distribution. If I know the normal distribution, you remember, I know how to calculate my probability using my G values. We have seen that. This is the G value, this area under the curve. Same old story. Okay. Now the question, why This one is a standard variance. This one, why it is a standard variance? Is the question comes into the picture. Now, I am talking about how accurate the information which I collected in the sample, right? We discussed about, is it that some my mu value when I'm giving a range, is it that plus or minus 10, or my range is going to be plus or minus 20, or my range is equal to plus or minus 30, or my range is equal to mu plus or minus 1. Suppose if I give you this kind of a range options, okay, to find out my mu value, that means from my sampling distribution, my mu of x bar, okay, is going to represent my mu population. But if my mu x bar is having a tolerance limit, let's say this is 5, whereas your mu is, let's say it is 1. If mu is, let's say it is 1. So the difference between these two is 4. That means my sample data or sampling data distribution mean is having some kind of this plus or minus kind of a thing, whether it is 1 or 10 or whatever is the magnitude of this makes the difference. In such a situation, which one you would like to pick out of these 4? Please respond. Do you pick this is the first one, second one, third one, fourth one? Which one you pick? Please respond. You pick the first one, right? Why do you pick the first one? Because if my mu value is 4, the difference, yes, it is close, because the difference between these two is 1, right? 5 minus 4 is 1. That means this value, my sample value, is much more closer to my population information. The more closer to the population information, the better I'm able to predict. That means the prediction results which I am going to talk about will be more realistic, will be more appropriate. Are you clear, my dear friends? Please respond. Others? Okay. This is called, this way of representing the 3 conditions and finding out your population is called central limit theorem. Very, 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 very important, and very, 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 very useful. This theorem you have to. But let us give you a definition of what is this CLT is all about. Many people, you might be hearing CLT in different forms, but actually the textual point of view, textbook point of view, let us give you the definition of it. Okay. Here, let me write it down so that you remember this. The sampling distribution of a statistic. What is the statistic? Statistics can be mean, it can be standard deviation, it can be minimum, it can be maximum, it can be variance, whatever it is. The sampling distribution of a statistics is the probability. What it is representing the probability. Okay, it is the probability distribution of all possible values, the statistic can take, or that the mean may take, or assume, may take or assume, you can write it as, when computed from random, when computed from random samples of same, random samples of same size drawn from a specified population. This is how your mathematics definition, my dear friend. But what it means is whatever I have discussed you so far. Okay, it is so simple. It is a you end of the day, what you are trying to do, you are trying to figure out the probability. From the probability, you are able to, how do you are going to figure out the probability? First, you are trying to figure out mu. From the mu value, you translate that into the normal distribution values, and then you get into the G score. From the G score, you move on to, let me explain that also. Okay, what is my Z value? X minus mu by sigma, right? So all the, see, this is the original definition. Now same formula I am applying to multiple samples which I plotted. I am applying to sampling distribution where I have the data points for all, where I have taken the averages of every sample. In such a situation, okay, the problem here is, you know, X, you know this, this mu is unknown, but this is known. How do I know this? You have the same formula which we discussed above, right? Your h square is nothing but sigma of xi minus x bar whole square divided by n minus 1. If I remove this n minus 1 and use n, then this becomes sigma square. Guys, you understand what I'm trying to say? Okay, we discussed this in the very beginning, first classes. So you have this value, you know the x, this value, then it is easy for you to calculate the g, because your mu, you will be taking it as some kind of a mu. That is why you need a this condition. Mu of x bar is nothing but mu. That means I am assuming whatever the mean I am getting from the sampling distribution as mu, and I calculate the z value. From the z value, I go into the pictures and I get the value of for my probability. With this probability, I can actually tell you how much is my, I mean, what is the my mu. That means whether mu is, you are getting 180 seats or 110 seats or 150 seats or whatever it is going to be. Okay. Are you with me, my dear friends? Is there any confusion here? Now there are two more terms I would like to define here. Now, the first condition is this: mu of x bar should be mu. Second condition, standard deviation is nothing but, you call it as, sorry, this is nothing but sigma by square root n. Now I will be telling you one thing. Suppose you have collected the sample S1, S2, S3, so on up to Sk. In each sample, okay, you may be including, let's say, maybe included 10 people. The size of the sample will be 10. Here, size of the sample S2 will be, size of the sample could be probably 15. This could be 20. This could be, let's say, size equals to maybe 100. Let us assume. When you have such a sample, each sample has my X1, my average, right? Are you with me? When you have such samples, and when you try to draw the histogram for all these things, this will be like this. For X2, it will be something like this. For X3, it will be something like this. For Xk, it will be exactly like this. It will be like this. That means this is your center. This is your center. This is your original mu. The more closer you move towards this from a defining a range perspective, the better accurate you are. The better accurate you are. Are you with me? So, what is this closure will do? Which parameter will talk about the, which gives you the insight about the closure to the mean? Standard deviation. That is sigma. The standard deviation, whether sigma or s, whatever it is, standard deviation basically will be telling you how much is my mean is actually separated, or variation, I mean, how far my values are separated from my mu. That is what the standard deviation. But when n is equal to 10, data is your graph is looking like this. That means your standard deviation is quite a more, I mean, it's far. When n is 15, it is slightly reduced. When it is 20, it is further reduced. Maybe this picture which I have drawn is not right. But when it is equal to k, it is further properly reduced. That means this is more closer to my mean. That means why such a situation is happening? Why standard deviation is becoming larger here? Because the sample data that you have is biased. Is not enough to represent the right picture. In other words, standard deviation is nothing but my error, because this will standard deviation is the indicator of how far my sample mean value is from my mu. Hence, standard deviation is called as standard error, which is nothing but sigma by square root of n. So the second condition is talking about standard deviation. Why we should talk about standard deviation? Because it is actually telling you what is the error. Depending upon the standard deviation, you can talk about how much is the error that you are committing. Okay? But at the same time, let me give you some more information here with the above pictures. So here, if the standard deviation is high, this is the high, standard deviation is high, okay, this height is shorter. If the standard deviation is small, the height is going to be taller. Okay, and at the same time, if it is small, you see this width is also small. Here, this width is also high. Right? Are you with me? So, Standard deviation of sampling distribution. This standard deviation of not sample. This is standard deviation of sampling distribution. Please remember, this reflects your standard error. Are you with me, my dear friends? When your data in the sample, is biased or not appropriate, okay, and the kind of x bar you are calculating, because x bar or x1 bar or x2 bar, whatever you are calculating in the samples, will have some inherent error. It has inherent error because you have not included right segment of the data points, or your number of records, the size of your sample is not enough to represent the true population. The size of your record, the sample data, is not a true representative of your population, because of which there is some error that is occurring within the sampling, within the average or within the mean that you are identifying for a sample. That error is called margin of error. Data science is the subject which will talk about how to minimize this standard error, how to minimize this margin of error in one single statement. That is what all about. This is what the data science is. Data science is one of the wing of the data science. Is talking about the inference statistics. The inference statistics is all about this. And this is where you use all big terms, generalization, what do you call, there are many concepts which we will get into. And when we get into the mathematical modeling, lot of effort will be running around how to minimize this error. That means how to take it to the closure, so that your prediction is going to be accurate. The more accurate the prediction, then you say you are a good data scientist. Okay. And they investigated, they did sort of samples, and they arrived at the third condition, which said that if in any given sample, if number of sample data points are more than 30, automatically your data becomes normal. When it becomes normal, you can calculate the z, you have ready-made available tables, and you can get the probabilities, and then you can do the prediction with more accuracy. Okay, these three properties, these three are the properties of central limit theorem. It is not fair to infer that the population mean is exactly it. You can't do that. So you can't give 1 point estimate saying that okay, in these elections BJP is going to win 180. It's not correct. You can't do that, and you can't measure such kind of. Rather, you can say they may get the seat somewhere between 175 to 185, or they may say 179 to 181, more precise. That means you minimize your standard error. That means you minimize your standard error. Okay, guys, are you with me? So some of you may have a question, how do I get my mu of x bar? That also, let me give you that information also. It's so simple, right? It's already, I said about it, but this mu of x bar is nothing but x1 bar plus x2 bar plus up to xk bar by k. Any questions, my dear friend? Are you with me? Okay. So having said this, now from here we will get into something called decision making day after tomorrow, Thursday. What is the decision making? Now you have arrived at the range for your mean. You have arrived at what is the range in which BJP is going to get the seats. But how much is the error you have done? What is the error? How much is the error? If you want to take a decision on this, what are the various errors types that you have to look at it is something which we will discuss on Thursday. Don't miss Thursday's class. Again, it is going to be very critical, very important. Because once you understand that, the rest of all your regression, logistics, your decision tree, random forest, neural network, everything is dependent on that decision making errors that we are going to talk about. Okay. And then we will use R programming. I will show you how you can do how you can calculate all these things. We'll take an example and we will do it. That it will not take 2 minutes or 3 minutes, because there are only 2-3 lines of code that you have to write it. It will generate you the picture. It will give you the answer. But if you don't know this theory behind, what you do with that programming? Okay. Okay, guys. So any questions before I stop the class? From here onwards, it will be very interesting. Okay. Now I will slowly take you into. You may ask a question. What if n is less than 30? That also we have a solution. Then there are so many data or types of data distributions we have to look at it. Okay, chi-square distribution. There are many other things which you have to talk about. Then we have to talk about proportion. Then we have to talk about multiple sampling. Then two sampling part. Then we will get into a wonderfully interesting concept called ANOVA. After the ANOVA, I think then before we reach there itself, I will be talking about what do you mean by crisp DM framework. And there are some more fundamentals I have to give it to you about your matrix algebra and coordinate geometry. That also we'll talk about it. And then we will step into simple linear regression. I will take you an example in R programming, and I will explain you the concept of this simple linear regression. In in that there are 5 dimensions which you have to look at it, which I will just tell you at a very high level and leave it there, because it becomes too much for you by then. After this, now I say, after that I'll say you are ready for learning data science. There you need a tremendous R programming and Python programming part, which is going to be involved. And you will be using all these fundamentals, which are you learned for last, which you are going to learn in these 40 classes, 40 hours classes, are helpful. And then you do something about it. That is called data science. Okay. Okay, guys. See you tomorrow.